So scientists began to have a change of heart then?
Right. They stopped trying to understand the subatomic realm in terms of the superatomic realm and resigned themselves to understanding it on its own terms.
So it was agreed that the subatomic realm is inherently indeterministic.
Not exactly.
How do you mean?
Among those who both understand and accept quantum physics, there are two views as to whether quantum physics is compatible with determinism.
Namely?
The one view is the one you described. Within the limits set by the uncertainty principle, events in the quantum realm are uncaused.
And the other view?
Before you can understand that view, there are a couple of general principles about the nature of deterministic systems that you must first understand.
Please tell me those principles.
When we describe a system as deterministic, what we mean is that it is deterministic in certain respects. Given a system composed of interacting billiard balls, that system is deterministic in the sense that, given the positions and momenta of the billiard balls at a given time t1, it is determined what their positions and momenta at later time t2 will be. But given what the colors are of those billiard balls at time t1, it is not determined what their colors are at time t2.
So that system is deterministic with respect to certain variables, but not others.
Exactly. And the variables with respect to which a given system is deterministic are its state variables.
Because the values of those variables at a given time determine its state, or at least the aspects thereof that interest us at that time.
Exactly. If a system is deterministic, it is deterministic relative to a given set of state variables.
And indeterministic with respect to some other choice of state variables.
Exactly.
And if a system is indeterministic with respect to one set of state variables, it may be deterministic with respect to some other set of state variables.
Exactly.
And there is some set of state variables with respect to which the subatomic realm is deterministic. Is that the idea?
Yes.
Could you be more specific?
Where subatomic particles are concerned, we don't know locations or momenta with certainty. So we shouldn't take location and momentum as our state variables, but we do know probable locations and probable momenta with certainty. Given each possible location, L, we know the probability of a given particle's occupying L at a given time t, and given each possible momentum, M, we know that the probability of its having an M at t. And these facts, taken collectively, constitute what we might refer to as that particle's probability profile at t.
Is that the term that physicists actually use, or did you just make it up?
I just made it up.
It's a good expression, though. When you said it, something clicked, and I think I know how to finish what you were saying.
Let me hear it.
Instead of taking positions and momenta as our state variables, we take probability profiles as our state variables.
Exactly.
Given a system of subatomic particles, the probability profiles of those particles at a given time determine what their probability profiles will be at a later time, assuming no outside interference, of course.
Precisely.
So that system state at t is completely defined by the values of the relevant state variables of the particles composing that system, and those state variables are the probability profiles of those particles.
Exactly.
And relative to that conception of what defines that system state at given time determines its state at a later time.
But it doesn't stop there.
How do you mean?
After thus revising the concept of a state variable, we must correspondingly revise the concept of location in spacetime.
I see. We must revise it in such a way that these new entities of ours, these probability distributions, have determinate locations.
Exactly.
And this, Dr. K, might be a good stopping point.
I agree. See you tomorrow, Max.